In this class, we are going to talk about pressure. Before we delve into calculation, let us understand what is meant by this concept, pressure. Pressure refers to the force exerted per unit area on the surface of an object or a substance. Let's say, please pay attention. Let's say we have a table. Then we have a book that was placed on the table. We have book here. This book will tend to exert a force on the table, and the type of force that the book exerts on the table is called weight force. Are you getting it? So the pressure generated by the book on the table. Now the book doesn't cover the entire surface of the table. I'm very sure you are aware. Now the area that the book covered, that area is what we are interested in. Are you getting it? So pressure can be calculated mathematically as P equals to force all over area. Please pay attention. Back to the example that I gave you. I told you that if let's say you place the book on the table, the book will exert a type of force called the weight force on the table. Are you getting it? Now, because the book covers a particular section of the table, that is the area that you are talking about. Are you getting it? So pressure mathematically can be expressed as force all over area. In this case, that means pressure is directly proportional to the force and inversely proportional to the area. And if you are well versed with variation, you will discover that means that if the force, okay, this is force, sorry, this is force. Now, that means that if the pressure increases, that means that the force will also increase. And if there is increase in force, there will be a corresponding increase in the pressure. Are you get what I'm trying to say? And because the pressure is inversely proportional to the area, that means that if the area increases, the pressure will decrease. Do you get it? Okay? Having understand what is meant by pressure and the mathematical representation of pressure. This is true for pressure in solid because we can also have pressures in liquid. Do you understand? Okay, let us look at work example under pressure in solid. Pressure in solid. Pressure on a solid surface. Are you get what I'm trying to say? Okay, please write down this question. A 15 kilogram rectangular box with a length of 70 centimeter and a breadth of 40 centimeter rests on a table. What pressure does the block exert on the table? Okay, please pay attention. From the information, we are given that the mass of the table, the mass of the block is 15 kilograms. So the mass, please pay attention. The mass is 15 kilogram, and then we are given the dimensions of the block. Okay, the length of the block is what? The length of the block is 70 centimeter and the breadth is 40 centimeter. Okay, now please pay attention. Don't forget that pressure P equals to what? Force over area. Are you getting it? Now we are given the mass and we are given the dimensions of the block. Okay, we need the force and we need the area, right? But we are given mass. To get the force, this, please pay attention, the force that the block exerts on the table is called weight force, right? And weight force is equals to mass times acceleration due to gravity, right? Are you getting it? Now the mass that we are given is 15 kilograms. So W, which is the weight force, equals to the mass, which is 15 multiplied by 10. Okay, so the weight force is equals to 15 times 10 is what? 150 Newton. Okay, now we are given the length. This is the force that we're going to use, weight force. Are you getting it? Now we are given the length. The dimensions of the block is of length 70 centimeter and breadth 40 centimeter. Now because the unit is in meter, you see, force is in Newton and area is in meter squared. Do you understand? Force is in Newton and area is in meter squared. So let me just erase this, okay? I just use this as an example. So the unit of pressure is Newton per meter squared. Do you get it? Okay, now we are given the length in centimeter and the breadth in centimeter. So what are we going to do? We need to convert both to meter, right? Now to convert centimeter to meter, what are you going to do? Just divide both units by 100. So for this, I'm going to have the length equals to 70 centimeter, and 70 centimeter in meter is what? 70 over 100. That is what? 0.7 meter. Okay, and the breadth is what? 40 centimeter. So the breadth equals to 40 centimeter. Now you can convert this to meter by dividing it by 100. So I'm going to have 40 all over 100. That is what? 0.4 meter. Okay, now the area now is length times breadth, right? Because now listen, please pay attention. If you check the question, you will discover that the shape, the base of the rectangular block, okay, it is a rectangular block. That means that the base area is what? Length times breadth, because areas of a rectangle is what? Length times breadth, right? So I'm going to take the product of the length 0.7 multiplied by 0.4, right? So the area will be equals to 0.28 meter squared. Okay, now having gotten the area as 0.28, we can now proceed to calculate the pressure. Okay, the pressure P equals to force. The force now is what? 150 newton. Okay, 150 newton all over the area, which is what? 28 meters, 0.28 meter squared. Okay, so the pressure here will be 150 divided by 0.28. That is 536 newton per meter squared. Okay, so that is the pressure. That's the pressure that the rectangular block generates. Are you get what I'm trying to say? So you can see that it's simple, and this one that we did here is pressure in solid. Are you get what I'm trying to say? Because the surface area of the table, is a solid surface. Are you get what I'm trying to say? We can also have pressures in liquid. Okay, and we're going to talk about that as we progress. Okay, let's look at more work example on pressure in solid.